So how many people, apart from you guys, of course, have been involved in a sort of forensic investigation of a reinforced soil wall, as we call them here in Australia? Anybody? No? Gee.
Only you,
Just me. And you. And Georgia. Yeah. So when an old boss of mine in Glasgow used to say that he knew when one of his designers really knew a code of practice or a design standard, if they could design something completely in accordance with the standard and still know that it was unsafe. So that's how he knew. That was his test. So that went in here as a young engineer, and it sort of stayed with me. And that's the theme of my talk. So we have a standard in Australia, AS 4678 reinforced soil structures. And within that standard, there are some cartoons. And I've got 3 slides of these, and these are the ones that sort of relate to reinforced soil walls. So, is there a little pointer here? Or? Oh, there it is. Sorry. So, which one's the? There we are. So sliding at the base, yes, that's sort of translation of the wall. We've seen that. You get a little bow wave at the front sometimes. So the wall splits in 2, slides on one of the reinforcement layers. We've seen that. This one I've never seen. I don't know how that can happen because generally the walls aren't stiff enough for that to occur.
It's no longer in the guidelines for the US.
Okay, good. This one, yes. This is a sort of rupture of the reinforcement behind the facing. We see a bit of that. Rupture of the reinforced soil wall facing. Yep, I've seen that. Can I change the slides with this as well? Yeah. Oh, gee.
use the other one. Inside error.
There we are. This one again is a sort of a translation, sliding forward. Seen that. This one I've never seen, but I can perceive how that could occur. This one is global stability, quite common in my experience. This one is really a bearing capacity failure, also quite common. I've never seen this one, but I can perceive how that might occur with pull out of the top reinforcement elements where they don't have as much normal load on them, giving them more frictional restraint. And this is another translation one. So these are the last 2 that are in the code. Bulging of the front face, yes, I've seen that, and settlement of the entire wall, and that might be a bridge abutment, for instance, it's where you get the bump on and the bump off the other side. So that's what AS46.
Go back one slide.
Yeah.
The bearing capacity failure is wrong, but it's wrong as well in the FHWA guidelines. So
Okay.
the reason is that bearing capacity will fail this way.
Yeah. Yeah.
Clockwise, not counterclockwise.
Yeah. Okay. So you'll notice from those, and that's all that the code says about mechanisms failure for reinforced soil walls. So there's nothing in there about climate change. There's nothing in there about bridge abutments at a high level on walls. There's no accounting for that. And certainly not in Victoria here, because IBS, your integrated bridge system, to Vic Roads IBS is irritated bowel syndrome. So going through some practical examples. This is one we're looking at in New Zealand right at the moment. Just started looking at this one. This one has translated forward, and there's a little bow wave here. You can see that there. And it's also bulged. And this is above the wall. You see there's a sort of telltale tension crack appeared in the car park surface above the wall. So that sort of covers these two mechanisms from the code, I would say. This one is a definite sort of failure within the sort of internal failure within the wall. So it might be a combination of a sort of semi-global failure at the back. It might be a sort of rotational thing here, happening here, and then it's daylighted out the centre of the wall, sort of thing. This one is riverbanks, so probably soft soils, probably not dealt with properly, bearing capacity failure, as well as some sort of maybe a global stability failure as well. This one. This one, the telltale one here. This is a bridge abutment wall. The telltale thing here is this tension crack, which has clearly been there for a while. They might wait till that becomes a nice mature tree and its roots, go in and stabilize everything. I don't know, but you can see the tension crack develop beautifully there, as well as the little step down. This one again, so one of the most common types of failure is the global type of failure, and that's probably what this is. Similar to this one and this one. So that's quite a common type. See it a lot, and it's often where a geotechnical engineer isn't involved with the design, so they haven't considered the global aspects of the stability. The rupture of the wall facing has occurred here. I've seen a few with concrete facings as well, especially the corners coming off the panels, where the panels rub together and have not been isolated properly from each other. And this one's the rupture of the reinforcement. So the reinforcement is it goes between the blocks, and it's just the blocks sit on the reinforcement and give it some friction, and obviously hasn't been enough for that case. So that covers the Australian standard mechanisms of failure. I would contest that in my experience the most types of failures that I've seen are due to either construction issues or water issues. So I've got some examples here. So this one's from the US. Now apparently, if you read the paper that goes with it, the contractor took it upon himself to, because there was some pipes went through here, so where there was a service going through, he just missed out a complete layer of reinforcement and didn't tell anybody. And that's why that one failed. It's a bit like George's state highway, no reinforcement. You can't expect it to work if it's not there.
Not the other there stayed.
Sorry?
The other one stayed put.
Yeah, but they put the reinforcement in there. This was the section that they missed it out on. Here's one that I from Melbourne. I went out to see this one about 20 years ago, and what there was a lot. It was a sort of tiered site when the walls up to about 2 or 3 meters high, and they were going to build houses on each tier. And what we did was we dug, forensic slots through the wall. And as soon as we did that, this is what we saw. So the contractor, not understanding how the reinforced soil wall works, just cut corners and decided he was too lazy to excavate back to here where the soil reinforcement should have gone, only excavated to here, and thought he was doing the right thing, and put the reinforcement went up the back. So there was all this crowded reinforcement up the back. So the reinforcement was the right length. It was just in the wrong place.
Well, at least if you use some pegs and paint it to
That would have helped a bit, but not enough, I think. So that, I mean, and this isn't historical stuff. This goes on today. So it points to the importance of supervision by somebody who is familiar with the design and knows how these things work. Water issues. So this was actually very similar to the ones you showed, didn't you? I might have been the same one. I don't know. This is from the US, and it's really it's a preferential water path. So it looks as if there used to be a creek there. They built a wall in its way, and the creek wants to start being a creek again. This is a recent one from Hong Kong, and it's a combination of construction issues, because this has failed during construction, and water issues. So what happened, if you read the paper, was that there's a drain down the back of the wall, which is good practice. It goes all the way down the back, but they had a really heavy rain event during construction, and they hadn't graded the surface away from the drain, and all the water went down the back of the drain, and this has failed through piping. So the groundwater pressures built up and piped through to the front, blew off the facings and caused sinkholes at the back.
Is that the best place to be standing?
Yeah, well, that's right. Probably not, you'd say. Oh, what's happened there? And this is the last one. This one's from Queensland during a flood. So this is a separation issue, I believe, where the water's got in to the reinforced soil and washed it out. So there's been a pathway for the water to get in and then to get out again and carry the soil with it. So some sort of filtration would have stopped that issue.
What's the reinforcement they use there?
Steel straps. Yeah, that's a Rico wall, but probably not constructed properly. Probably missing some filtration.
It was so you can see that it's not an integral.
No, that's right.
So
Yeah.
You can see the piers.
Yes. Yes. Yeah. Because it's in Australia.
Mm-hmm.
Yeah. Yeah. So take-home messages.
For the breach now, aren't
Yeah. So take-home messages are, make sure that you understand all the potential mechanisms of failure before you embark on design, and make sure that you recommend proper supervision during construction. Thank you.
Thanks, Allan. For those that remember it, we had people on the wall there a few days before, and it was creaking and groaning, which is not a great sign.
Saying they stop the traffic and people like that. Stop them, stop!